Hello guys, so let's continue our binary search series. Today our our question is farthest number. Okay, farthest number. So let's see about the question, what the question says. So farthest number says given an array of size n, for every element in the array, the task is to find the index of farthest element to the right of the array which is smaller than the current element. If no such element present, then print -1. So let's take an example and understand the question. Let's say the example, take it same as that given example. So array is 3 1 5 2 4. Array is 3 1 5 2 4. So what you have to do? You have to print output for each element. You have to find the farthest element in the right of this tree which is smaller than 3. So which are the element here smaller than 3? 1 is smaller than 3, 2 is smaller than 3. But what you have to choose? You have to choose the farthest one. So 2. What you have to print? The index of 2, not that element. You have to print the index. So 0, 1, 2, 3, 4. So the index is 3. So you can see that output will be 3 for this case. Now for 1, is there any element which is smaller than 1? No. So you can print -1. For 5, 4 is the farthest number which is smaller than 5. So you can write 4. For 2, there is no element. For 4 also, there is no element smaller than 4 on its right. Okay. So we are searching in the right side. That's all. So this is our output. Now, let's look at how we can do it. You can simply do a brute force solution, that is for each element, in the array, what you can do, let's say the index is I, you can search for element in the range I plus 1 to n, search for the element in range which is less than current element, but less than ith element. Okay, so the element you will get at last will be your answer, and if you don't get any element which is less than ith element, so your default answer will be -1. So that's how you can do it. If you see what will be the complexity for this approach, so you will be running two loops. First loop will run from I equals to 1 to n, and second loop j will run from I plus 1 to n. So your complexity will be order of n square. Now can you do it better? Yes, obviously we can do it. We can do it using binary search. Now you can say that how we can apply binary search, because the array is not sorted. Obviously array is not sorted. Can we sort the array? No, we cannot, because the position of all the element matters to me. So I cannot directly sort our array. Okay. So let's see how we can solve this question using binary search. Okay. So yes, we cannot sort the array, but look at this example. The example was 3 1 5 2 4. 3 1 5 2 4. Now for 3 we want a minimum element, that is an element which is less than 3 in its right. So what if we just write from the right minimum element from the right side? If we keep only minimum element on the right side, less than 3, for finding the element which is less than 3, we can search here in that right minimum array. So how we can build that right minimum array? We'll start from right side and we will push our minimum element. Like for 4, 4 is minimum. 4 and 2, 2 is minimum. Now currently 2 is minimum and here it is 5. So 2 is minimum. For 1 and 2 we have. So 1 is minimum, and for the last time also 1 is minimum. So that's how we can build our right min array from the right side. Minimum array. Now, okay. Now consider for 3. So here was that 3. For 3 we can search in this range for an element which is less than 3. That's what we have asked for. We are finding an element which is less than 3. That is here, and index of this is 2, nothing but 2. So we can give our answer. Okay. Now that's okay. That's clear, I think. Right min array. Now for searching, when we are searching here, what we can do is that this is a right minimum array, and this array will be always sorted. That's the main thing, because consider when you are coming from here, you will update your current element only if you are getting an element which is smaller than the current minimum. So that's how it will be already a sorted array. So you can apply binary search here. That's all. Now let's see the cases when we will not get any minimum, like any farthest number. What happens to that case? If you see, like for 5, here we have 5. No, for 5 we have, like for 1, here the element is 1, so we will find for an element which is less than 1. Now obviously we will not get any such element, isn't it? So our pointer will be where? So if we use the function of a lower bound, our pointer will point to that first element, which is here. So let's implement this, and along way we will understand about the question. So first, our task is to write the function, write the code for minimum, right minimum. Okay. So vector int, we will have our right minimum, which will be of size n. And the right at the last element of right minimum, we can fill it with array's last element. We just simply writing the code for the finding right minimum. So for int I equals to n minus 2, I greater than equals to 0, I minus minus. So what we can do, right minimum of I equals to minimum of array of I, the current element we have, and the before minimum we had, that is I plus 1. Okay. So that will be right minimum of I. Now we have built our right minimum function. Now we will find the element for each, the index for each element. So for int I equals to 0, I less than n, I plus plus, we can, for storing the answer, we have to create an answer variable. So that is, let's say, vector int n comma 0 of size n. Okay, so not 0, let's initialize it with -1. If we get any position, then only we will update, otherwise we will let it be remain -1. Okay, that is the default answer. Now, so first we will find a position in that array, farthest number array. So we will use the function lower bound. Lower bound, we will start searching from begin plus I plus 1, current element plus 1, because we will exclude current element and we will start searching after that from here to last. Okay, for the element array of I. Okay, now we will have our position and we will find out the distance, that is equals to distance of array of begin to position. Okay, so we will have our distance and we will minus 1 that distance, because for the number 3 we will get this element as a pointer, so we will minus 1 so that it will come back to I. Now if our distance is equal not equals to I, then only we will update our answer of I to that distance. Okay, so we can return our answer. Let's run it. So okay, the output is correct. Let's submit our code. So there is a problem of here it is -1, this is 7. Okay, so the problem was we are searching from the array, but we have to search in that right mean that sorted array. So we have updated array with right mean, this tree name. Okay, so we can search here and we will get our distance and we can return our answer. Thank you.